Hey, so today we're going to talk about improving developer experience, and I'm going to focus on some of the tools that I built and some other people built, and techniques that can make your life easier as developers for iOS in general. And like I was introduced, I lead at the New York Times, but I also do a lot of open source, so you might know me from Sorcery, but I have a lot of projects, a little too many to maintain very well. So all of those tools, if you ever use any of them, are focusing on making your life easier as developers, making your day-to-day job a little more manageable. And so this is a topic that I am very excited about and something that I've been focusing in the last decade on. So hopefully you'll find it useful. So the developer experience can make a really big difference for your team, for your project, across your whole company. And investing time into improving that will yield very big benefits. So, there are things you can do that make small change, small difference for you, like, oh, maybe you make a little better API, and there are things that can affect everyone. And this is what you are looking for, like not just making your personal life a little better, but making the whole team a little better. So let's look at some differences you get with bad developer experience versus a good one. So if you have a bad developer experience, you have to waste time doing things that are not really important, dealing with the bad tooling. So like, for example, Xcode might not be the best, or some of the other tools that you built in your build process, like your CI, might cause issues. Your architecture might make things that are bad easier to do than the right ones. And all of that makes you inefficient, and it creates roadblocks in your way to deliver the best features your users would want. And so, for me, what matters is that you work smart, not necessarily hard. You don't want to kill yourself when you're doing your job. You want to, have the good flow, find that flow that you are focused on, and you can focus on delivering the features that your users really care about. So your workflow is efficient. It's easier to keep connected with your work. So as you are working, if you have roadblocks thrown in your way every couple of minutes, that means that you disconnect from what you were trying to fix. Let's say you're working on UX, right? When you work on UX, you need to really focus and tweak things very often, a lot of the times, and then you get this nice experience, this nice animation, or this, this kind of connection with the user. If you have to take breaks to deal with problems that your workflow has, then you kind of lose that. You don't really experiment so much, and as humans, we do a lot of mistakes, and it's very common that, when you're overworked and when you work late, you make mistakes that are really stupid. Even if you are very senior, even if you have years of experience, we all can make really funny or stupid mistakes, depending how you look at it. So what we want to do is we want to keep our focus on the things that really matter for the end goal, which is making great apps. So let's look at a couple of the common issues. So there was a talk about tracking retain cycles, and this is very common in our development, especially as we use more and more closures in our apps. It's really easy to create a retain cycle and don't realize it. So everyone here had to deal with that, I'm sure, so I'm not going to even ask. So Apple gives us Xcode memory graph debugger and leaks instrument. They also give us static analysis, but it doesn't find that many issues regarding that. But the problem with this is those tools are great and very helpful, but you have to run them when you want to check for the memory leaks, right? You have to think about, okay, I need to run instruments and see whether I introduce issues. Now, the problem is most of us are lazy. Humans are lazy. And so what happens in my experience working on multiple different projects is that people only run this when they get feedback that something is wrong. So if your app crashes in production because you're out of memory, then people are like, oh, we probably have memory leaks. So they go run instruments and they found like there is a ton of issues. That is a little too late, because when you have, like for example, with the memory graph debugger, it works great for object retain cycles. So if you have one object retain another object and then it retains the other one, right? You have the cycle. That shows up great in memory graph debugger. But when you have closures, that doesn't really work that well, because closures are not displayed as clearly. It's a little more complicated due to how the memory access works. So the problem is, if you wait until you run these tools, you have a lot of code to check. You have a lot of the git diff to see what actually caused the issues. So if you run it every month, I don't want to be in your shoes, because there will be so many changes that could have introduced the retain cycles that you will waste hours, if not days, to find those problems. So what you want to do is you want to find a way, either somehow make it so that people actually run this every time they make a PR, which is very unlikely in my experience, because people just don't do it. And there isn't really a built-in automation to make sure that people check that. So what I thought about is, when I was working on the New York Times application, I was fixing retain cycles, right? And I fixed retain cycles in 1 month, and then the next month I get the task to fix retain cycles, because they appeared again, and we're leaking memory again, and we're getting crashes in production, and we have millions of users. So I thought to myself, how can you do it preemptively? So there is this simple thing you can answer. For most classes in your project, you know how many instances of that class should live at any given point. So if you know that, then it's a simple manner of tracking how many instances are alive now. So there's literally an integer for each class that tracks how many of them are alive. So I built this simple tool called Lifetime Tracker, and the way it works is you conform to lifetime trackable on any object you want. It doesn't have to be a view controller. You say how many instances you can have, and then you just call lifetime. And it automatically uses some runtime to register on the init to decrease the counter. And that way, as you work, you find the retain cycles as they happen, instead of a month or 2 months later. Another issue that's very common is long iteration cycle. The problem with waiting for build times is not just the fact that you're wasting time, it's also the disconnect that it creates. So if you're working on UX, you don't want to have long breaks between your code changes. So just so much for you, if your iteration is 25 seconds to build and deploy and run your application, and you get to 300 iterations per day, that's 2 hours waiting for the build times, which is terrible out of 8-hour workday. So there are a couple of things. First of all, split your projects into many frameworks. Not only does this improve modular design of your application, it makes your public API better. It enables use of Swift playgrounds for your small projects to test your specific module. The one issue you can run into is dilip loading, but you can use static frameworks with Swift now, or you can use CocoaPod's static plugin if you're using that as a dependency. And this might be a little complicated in big projects, because if you didn't think about modularizing your app, you have a lot of dependencies across each class. And if you cannot split up, what you can use is injection for Xcode, which is basically a code injection framework. This works in Objective-C and Swift. It is not ideal for Swift, so it won't work with pure Swift classes, since you cannot swizzle them. But if you use UIKit still, not Swift UI, then this works very well for UX and UI work. And it's an external application you have to install, and there is no need to unsign your Xcode or anything like that. It's just an application that runs in your system tray, and then you just observe the changes, and it automatically compiles the project in real time. And on top of that, I built a tool a couple years back called KZ Playground, which also works in Swift and Objective-C. It has custom DSL for exposing control variables, so rather than having a number in code, you can expose a slider that you can adjust, and you can have an image picker and a lot of other stuff. And this is very simple to integrate. It's just a framework you add to your project, and it works great with injection for Xcode. And this is how it looks like. So you basically have, let's go back, sorry. So you basically have this iPad app that hosts your code. On the right, you have a worksheet. On the left, you have timeline view. And as you change the code, in real time, it just reloads. So I wrote this when the original Swift 1.2 was released and the first playgrounds, and they didn't have interactions, none of that stuff. So I wanted something that's more powerful than what Apple had, so I built this. And this works really well still, and I used it often for UX work because it's very fast. It's extremely fast due to swizzling being actually faster than running Swift playgrounds. Obviously, if you have modularized projects, just use Swift playgrounds, since that works out of the box. Another issue that's very common is boilerplate, and I truly hate boilerplate. This is something that kind of, as a programmer, I think to myself, I want to be doing things that are unique, and there's no point for me, for a human, to do things that are repetitive, right? If I have to write the same code over and over again across multiple types, that just doesn't sound right for me. That's not my job. That should be a computer job. That should be automated. So Apple gave us derived implementations of equality, hashing, and codable. They're great. They kind of lack control of, like you cannot do fine-grained control. So if you want to skip a variable inequality because it's transient, you cannot do that. With codable, it gets a little more complicated. If your structure on the server is a little different than what you want on your Swift structure, then you have to do manual implementation. The moment you start using manual, then you lose all the benefits. And this is not generic solution for all the boilerplate. It's just very specific. It's still great they gave us they made it for us, but it's very limited, right? So I built this tool before those things existed called Sorcery. And Sorcery is a Swift code generator. It's not a code dependency for your project. It's like a preprocessor. That's the way you can think it. It runs before your compile phase, and it generates more code for you based on your, basically it scans your whole project. It learns about it, AST, so abstract syntax tree, which types have which variables and stuff like that. And then you can write simple templates that generate more code for you. And that code gets generated, so there's no magic, there's no runtime. It's all basically just compiled code. And Sorcery is used in over 30,000 apps. People at Apple were using Sorcery. And Sorcery also introduced Swift annotations, so you can annotate types and variables with extra information that you can use to fine-grain control your templates. So if you have auto-equality in Sorcery, you can just add to a variable skip equality, and then it disappears from the generated code. So this is really useful. It also comes in with bundled real-time programming. So when you are writing your templates, rather than having to rebuild or rerun for Sorcery, you can just do Sorcery -- watch. And as you write code and save your template, in real time, it regenerates everything. So it's extremely fast to learn how to write custom templates. And so Sorcery, one of the benefits is not just automation across multiple types. Like, it's really good for like mocking and stuff like that. But what's really beautiful about this is it actually allows new levels of code design. You can use Swift as a DSL or like a data design. So you can create a structure that describes how you want the data to look and use Sorcery to generate all the boilerplate related to getting it from the server, translating it from a different format. All of that can happen. And you just have to write your custom templates, which is really useful and not that hard. Another boilerplate issue you might have is assets, right? You don't want to deal with strings for like things like colors, fonts, storyboards, localized strings. Apple has been fixing that for us as well. They've been adding more and more type support for this. But SwiftGen is a really powerful tool that also uses templates to generate a lot of typed API around all of those things. And so if you use Sorcery, SwiftGen is a natural companion. It uses the same dialect for Stencil, which is the templating language. So this is really useful. Another issue that is very common if you do testing, and I saw in the previous talks that everyone here did testing at some point. So this is Xcode comparing two articles. That is the message if they are not equal. I would like to wish you good luck understanding what is wrong. So this is not something we want. This is absolutely terrible. So what you can do about this? So there are actually two things I built. So Sorcery has a property level diffing template. So for each type that you want, it will generate property level diffing, so it can tell you exactly what is wrong. And I also built, if you don't want to use Sorcery for some reason, there is no good reason, you can use difference, which is a micro framework I built using the Apple-provided mirror type. And it does the same thing. It basically gives you, this is the same code, by the way. So the difference between this and this, it's a matter of including that single micro framework. So that is really powerful and can make your life much easier. The other thing that happens in testing is you need mocks. If you have protocols, and everyone that does testing writes a lot of protocols, you don't want to maintain that by hand, right? Every time you change your protocol, you will have to change all of your stubs or your mocks. That is a waste of time because you know what you want, right? In tests, you want to verify whether a method was called, what were the arguments, and this is always the same thing. It doesn't matter which protocol you're running, it's always the same kind of algorithm that you're doing in your tests. So again, two tools here. Both are based on Sorcery. So Sorcery comes bundled with auto-mockable template, which gives you a very simple API to generate mocks. And those mocks are They are not very beautiful from like the reading perspective, but they work really well. So you basically have a mock, and then you can see what the received arguments were, whether the method was called, all this stuff, it can answer for you. If you want something more powerful, like if you're a fan of OC Mockito or OC Mock, then you can use Swiftable, which is built on top of Sorcery, and it gives you the API of type, like, given this situation, verify that this object got called with this method and this arguments. So it's a more typed and nicer to read API. So use whichever you prefer. Another issue that's very common is data dependencies, and this is something that I hear from all the teams I have ever worked for. Like, people say they are blocked, they cannot work because the server is not ready, so they cannot work on the iOS application. And I say it's bullshit, because if you use testing, if you use protocols, you can mock all this data. As long as you have the API contract agreed with other people, you can work on your part. So the way to do it, the easiest, is to design your whole processing as a pipeline. And at each stage, you want a protocol. So you have like data provider, decoder, model converter, and then you have the consumer, which is a view model or whatever your architecture uses. And that allows you to do a couple of nice things. So if you're writing tests for your view model, or your bug report requires specific data, you just replace the model converter part with just fake models, just directly. And then if you do tests, you just provide it and then run tests. If you don't do testing, you can still use this pattern and just load the view with the fake data that reproduces the bug, right? So that's very easy to do. If you need to track mutations, which is where most issues are. Most issues don't happen because the first time you load something, it just loads incorrectly. That's easy to fix. What happens most of the time is that the data mutates on the server, and then you have bugs related to state tracking. So I built this simple tool called File Watcher, and this again works in Swift and Objective-C, and it gives you ability to easily observe file changes, whether there's two versions, local, which is you put a file on your desktop, or remote, which you can put a file on AWS or your Dropbox. And this allows you to do very simple thing with your flow. You replace the data provider with File Watcher adapter, which is like 3 lines of code, and then you can do stuff like this. So basically, this is the newsreader a couple years back. And what I have here is on a desktop, I have a massive JSON file, like ridiculously big. On the right, I have the whole section front, how it looked a couple years back. It looks much better now. And as I change stuff on the text editor and I save, the application gets updated. The servers were not ready at all when we were doing this. So this allowed us to work on designs and layout transitions very easily. And the framework is like 200 lines of code. So it's not complicated. Another thing that's really useful is data reproduction. So if you work on an application that has dynamic data, let's say your data, like newsreader, right? New York Times releases so many articles that every day there's like completely different set of data. And now the problem is when you get bug reports, in no company that I ever worked with, you would immediately start working on a bug, right? So it usually takes a while between getting a bug report and actually having developers work on it. The problem with that is, especially with dynamic data, is by the time you get to work on something, that data is gone. And if that data is gone and your app is pretty complex, it makes it really hard to reason about what was wrong. So you want to be able to reproduce data. Like, you can easily do this if you have unidirectional data flow, but who has that? And if your application already exists, there is almost no chance you will be able to redo architecture just for something. This doesn't happen. Let's be practical. So there is a simpler way. So in your data provider, in the pipeline, what you can do is every time you run your application, like a beta version, for example, you just, by default, save every raw data you get from the server with unique identifier. You save it to file on disk. If the user decides to send a bug report, you just pack everything from that folder that you saved all the data and send it to server with your unique identifier. You can then use either File Watcher or just build the download part when you download that blob from your AWS storage. And then you change the mode in your data provider, right? You change the mode to replay. So rather than using the real data it downloads from the server, it just replaces the data from the folder. So you can create a simple class that has a single function called process that gets input data and unique identifier, and it returns data. And you connect that to every operation you have, network operation you have. And if you do that, then depending on the mode of your project, you can either record that data and return the input data, or you can replay all data you had. And now you can reproduce all the bugs. I have a detail like this. This isn't very detailed. I have an article on my blog post that goes into detail how this works. Trust me, it works perfectly. Integrating this into project takes 10 minutes, which is ridiculous, and it can save you a lot of time. If you have unidirectional data flow, you can build something better because you can reproduce user actions. So this was actually built back in Objective-C. There is no code here. There is only annotations in Objective-C, and it's using runtime to reproduce everything. So it's not even unidirectional data flow. It's just crazy runtime magic. I was bored. So what I'm doing is I'm doing a couple of steps, including asynchronous operation. Then I'm sending it to the server, and then I relaunch the app and just load that, and I can go step by step what the user was doing. So that's what you could do in Objective-C if you were crazy. You cannot do that in Swift. But you can do it with unidirectional data flow. So if you're starting a new project, consider your developer experience. Unidirectional data flow is amazing. It allows you to reason about the code. It allows you to do time travel and record events. So really powerful. Another issue that's very common is doing manual steps. So people using, like, you have an application that has login screen, and if I got a penny for every time people working on features would just enter their freaking login credentials each time, I would just, yeah, it is crazy. Don't do that. Don't write code don't hard code your credentials either, because then you cannot commit. You have git changes. Use user breakpoints. That's what they are for. User breakpoints don't leave your machine. You can use expressions in user breakpoints, so you can fill in the fields for your text field for the login and for the password, and it's really easy to disable. So you can work across different branches, and you can keep them alive, and you can just mark them and avoid writing your own credentials each time. It makes no sense. And if you really need long-running features, you can do a build phase script that defines based on your username. So if I'm working on AR, I don't want to go through the whole newsreader navigation. I would just run this build phase script, and then I can do if mirroring, just go straight to the AR. So I launch the project, and it goes into AR directly. So in summary, good developer experience is something that you should really care about. In my opinion, it should be one of the crucial things you consider when you are designing your architecture. Because design of your architecture will decide whether you can build a very good developer experience or you are left with something that's really hard to reason about. And investing time into this part of our architecture and our experience across teams will yield amazing benefits. The bigger your team is, the bigger benefits will be. If you have 2 people, obviously it doesn't scale as well. It's still better for you. You're not going to waste time, right? But if you have like 20 people, that's big, right? Let's think about this this situation. People are willing to accept small amounts of pain if they happen over long periods of time. So let's say you're working on something and you spend 5 minutes dealing with some pain point. Whether it's tooling, whether it's your architecture, you waste 5 minutes today. Then you waste 5 minutes tomorrow and the day after. A lot of people will accept that because it's just 5 minutes. But if you change your perspective and you start thinking, well, if I am hitting this issue, it's probably that everyone on my team is hitting this issue, right? So let's say you have 20 developers. So it's no longer 5 minutes per day, it's 100 minutes per day. And then during weeks and months, you see how much it adds up, right? So at that point, you should consider, is there something I can do to make this easier, to avoid this issue? And I don't believe in the 10x developer, but if there is someone that is 10x, it's a person that makes 10 developers faster and more efficient, or just make their life easier. That is where the value is. Thank you.